सो वेलकम फ्रेंड्स टू अवर चैनल सीबीएसई साइंस लवर। जी हाँ, आपका एक बार फिर स्वागत है। सो एस्टरडे इन आवर प्रीवियस वीडियो वी हैव डिस्कस्ड अबाउट द different physical state of the matter, and now one question I raise to you, that are the different stages of the matter can be interchanged? So, my dear student, it is possible to change the one physical state into another physical state. So, I have prepared one graphic presentation to you. So, our today topic is interconversion of the three state of the matter, that is solid, liquid, and gases. Our solid state, liquid state, as you know that matter exists in all the three physical state: solid, liquid, gases. We are familiar with water. Water, the liquid state of the water, by which we are familiar. We use the water in liquid state, and the solid state of the water is the ice, and the gaseous state of the water is the water vapor. But my dear student, remember all these physical state at a normal temperature and pressure, or we can say that at atmospheric pressure in which we are living, or in which all the substances are kept. So we consider the liquid, solid, gases as per our atmospheric temperature. So student, the solid, liquid, and gaseous phases can be interchanged. How all these can be interchanged? So by increasing the temperature. Just if you increase the temperature from the solid phase, this is, you are showing the solid phase, particular view of the solid phase of the matter, and when you increase the temperature of the solid phase, then what happens in the particular structure of the solid? And let's see, when we increase the temperature of the solid phase, then what happens? This temperature just overcome the interparticular force between the two particles. Interparticular force, IF represent for the interparticular force. So when we give the energy, means when we increasing the pressure, we are giving the energy. So when we give the energy to the solid state of any matter, then this energy overcome the interparticular force, and due to the overcoming of interparticular force, the solid start to change into the liquid phase. So this process start when you continuously give the heat to the solid phase, then the heat just overcome the interparticular force, and when an optimum amount of heat which is sufficient to overcome the interparticular force of solid phase, then the solid start to convert into the liquid phase, and then we go from the solid to the liquid by increasing the temperature. But remember student, when this process start to change the solid to liquid, then at this phase the temperature remains constant. Temperature remains constant. So at the phase changing phenomena, means at the time of phase changing, the temperature remains constant. Why? Because at this time, whatever the energy we are giving, this energy trapped by the solid phase, and this energy just used by breaking the interparticular force between the particles. That's why the liquid phase, at the same temperature, the liquid phase has the more energy, because this extra amount of energy which is used by the solid to overcome the interparticular force is said to be the latent heat. Latent heat, student, latent word meaning is hidden. So that is hidden energy, छुपी हुई energy. So it is height and used by the particles to break the interparticular force, and then the solid converting into the liquid, and this during this phenomena temperature remains constant, and the temperature remains constant up to the complete solid converted into the liquid phase, and this hidden amount of energy is said to be the latent heat. Like this, if you increase the temperature further, then further the energy absorbed by the particles, and when this energy would be sufficient to overcome the interparticular force, then the liquid phase start to change into the gaseous phase, and particles move and start to escape the system. As we know that in gaseous phase the particles have much more energy with comparison to the liquid phase and solid phase. So student, what happens if we are giving the energy, then what is changing in respect of interparticular energy, in respect of interparticular force? The energy which we are giving to the solid phase, that is overcoming the interparticular force, and this energy absorbed by the particles, so interparticular energy continuously increasing. It means when we give energy, then interparticular energy increases, and this interparticular energy and particles start to move rapidly, and when the energy becomes sufficient to overcome the interparticular force, then the phase changing phenomena start. So student, in this picture you are seeing, then when we are rising the temperature from solid phase, when we start rising the temperature, then first solid phase converted into the liquid phase, and when you continuously increase the temperature, then the liquid phase converting into the gaseous phase. So see in the picture what is happening with the interparticular spaces. See the interparticular space in between the particles in solid phase. Now see interparticular space in the liquid phase. Now the interparticular space in the gaseous phase. So interparticular space is continuously increasing. It means if the interparticular space increasing, then we are going from the solid to the gases. So we have given the different name to that phase changing phenomena. So when solid convert into the liquid, then this phenomena is said to be the fusion. And when liquid convert into the gases, then this phenomena is said to be vaporization. When gas convert into the solid, then this phenomena is said to be deposition. So like that, the reverse phenomena, my dear students, when the solid convert into the liquid, that is fusion. When liquid convert into the solid, that is said to be solidification. Solidification, or we can call freezing. Like that, when liquid convert into the gas, that phenomena is said to be vaporization. But when gas convert into the liquid, that phenomena is said to be the condensation. So my dear student, when solid phase converted directly into gaseous phase without going to the liquid, that special phenomena is said to be sublimation. My dear student, when we give the heat, so an optimum temperature, the solid state start to convert into liquid state. That optimum temperature is said to be the melting point. Means melting point at which any solid phase start to convert into liquid phase. Like that, when you give the heat to the liquid phase of any matter, then it start to, at particular temperature, it start to convert into gaseous phase. That particular temperature at which any liquid start to convert from liquid phase to gaseous phase, that is said to be boiling point. For example, when we heat the ice, then it start to convert at its melting point, that is 0 degrees, and the boiling point when we boil the water. So boiling is a phase changing phenomenon where the liquid phase is converting into the gaseous phase. So in case of water, the boiling point of the water is 100 degrees Celsius. It means water, the liquid phase of the water start to change in the vapor form at 100 degrees Celsius. So these are the different phase changing phenomena that we discuss, and at each phase changing phenomena, temperature remains constant. But where this temperature goes at this time? Means at this time we are giving the energy to the system. Phase is changing, but the energy which we are giving, where it goes? So my dear student, the answer of this question we will discuss in our next videos. So by all these summarization, we are able to know that temperature is responsible to change the phase. But my dear student, instead of temperature, is there any other factor which is responsible to change the phase? So yes, there is another factor which is also responsible to change the phase. That is the pressure. Why? Because if you apply the high pressure on a gas, high pressure, under the high pressure and low temperature, gas converts into the liquid phase, and that process is said to be liquefaction. That process is called liquefaction. So when we store the gas into the container, then we have to pressurize it. We pressurize it at high pressure and reduce the temperature, then it becomes liquefied and we can store it easily. And that's why our cooking gas has named a liquefied petroleum gas, because it is stored by putting the high pressure and reducing the temperature. Then only it can be stored into the cylinders. So my dear students, these all about the interconversion of the free state of the matter. So we change the different physical state of the matter by temperature and pressure. So there are some specific terminological phenomena also we have, which we will discuss our next video. And then be with us with our channel CBSE Science Lovers.